Thank you everybody for coming to for signing up, coming to listen to us on this webinar. It's going to be about the latest technology that's available from NavVis, being their new handheld mobile scanner, the MLX. Just before we start, I just want to mention if you guys do have any questions, please do put it in the chat box. We will answer. There will be questions at the end. We will get to your questions. So if you could just turn off your cameras and microphones during the presentation. And also note that we will be recording this webinar. So if you, it will be made available via our website, and you will receive a link to the webinar afterwards as well. So just I'm going to introduce the speakers that we've got on our webinar today. I'm going to go from left to right. I'll start with myself. I'm the technical sales and support person for BuildingPoint, for their field technology division. I have a background in construction and survey. To my left, we have Sven van Duffelen. He is the Director of Global Channel Sales for NavVis. Sven is an experienced commercial and business leader with a history in working in the fast-paced and rapid growth tech business and startups, with some of these being in the geospatial and SLAM space as well. So he's got a lot of experience with the SLAM business. Then we have Ian Thompson. Ian Thompson graduated from the University in Cape Town in 1986 with his BSc in survey and is a registered professional surveyor. He registered in 1989. He is a member of the South African Geomatics Institute. He joined his practice in the early 1990s. He surveyed in the UK, Holland, and most African countries south of Kenya. He's currently the director of Jennings Goulet Thompson, trading with a common name, you'll know them as Cape Survey. We also, on the far left, we have Chris Keatley. Chris recently joined the BuildingPoint team. If you've not heard from Chris already, I'm sure you will hear from him in the near future. Chris is now the manager of our field technology division. And like myself, Chris has an extensive background in both construction and surveying. And I'll let Chris just take you through how his division sits within the greater group of a business.
So just before we get there, just a quick run through of the agenda itself. I'm not going to run through this. You can have a quick look. You can see we have allocated a time slot for Q&A, so please feel free to leave those in the chat box, as Brent has mentioned. Just a quick look at the Optron Group itself. The Optronic Group was established in 1986. We were the first Trimble resellers outside of the US, which was officially launched in 1987 here in South Africa itself. And then the Optron Group consists of 5 different subsidiaries. Those different subsidiaries, you'll see we've got Optron Pty Limited. We've got the Optron Pty Limited Group typically services your land surveying industry itself. We've then got SciTech. SciTech offers machine control within your civils industries. Vantage machine control within your agricultural or farming industries. BuildingPoint, which is where we are allocated right today. BuildingPoint services or manages the Trimble's building portfolio, as well as NavVis hardware and software solutions for the AEC industry. And then Moyle, I like to feel, actually ties all of this together. So what Moyle does is provide professional services, such as sort of creating specific workflows within your different industry, within all of these 4 different industries or subsidiaries that I've mentioned here today. As I mentioned, we today are from Building Point, and yeah, we look forward to just introducing you guys a little bit more to the NavVis MLX range.
Yeah, so just a little bit about this OnPoint series. Our field technology division that myself and Chris sort of sit in, we've got a whole bunch of office software, things like stuff for structural engineers, Tector Structures. We have stuff for the architects like SketchUp. A lot of our Trimble Connect, our common data environments, RealWorks for our point cloud processing. And then some of the hardware, that's where I get to spend most of my time playing with things like the GPS receivers, all the robotic total stations, and a lot of our focus on 3D laser scanning, static and mobile now, augmented and mixed reality. Those are also things which are becoming quite popular in construction at the moment. And I think a lot of what we do is we look at the stuff that you have within your business, look at this technology, how we can integrate what we have with what you currently do, have a look at the workflows, how we can optimize those, and basically in the end assist you with things like better communication and better collaboration through a whole bunch of these tools. There's communicating from your software to your hardware, there's communicating between your clients through common data environments. That's kind of what the point of the series is, to try to show you some of those workflows. And I think today, if we first take a look back and we see sort of 30 years ago how the market was dominated by total stations, people capturing maybe a point every couple of minutes. We moved into the early 2000s, static scanners, when we started to capture now millions of points per second. And I think now quite recently we've sort of seen a move towards mobile mapping. Actually, I don't think it's not that recent. It's been around for quite a while, but I think for a long time we've overlooked this technology because we haven't really seen it as applicable to our AEC industries we serve until sort of the NavVis has come along, and we'll see now, because of the quality of the data that it's producing and how that technology is now moving, its quality is moving a lot closer towards that sort of the middle picture of the static scanner. It's now opened up to become a proper play a pivotal role inside the AEC industry. So yeah, I'm going to hand over to Sven, and he will take you through their latest and greatest in that space.
Yeah, happy to do so. Just quickly, I think it's actually quite a unique opportunity being here with a reseller and a customer. So it's the first I've done one of these where customers sat next to us, but which is great. It's good to, it'll be great to see what you guys are doing a little bit later on. But what I wanted to talk about specifically over the next few minutes is NavVis over the past, let's go back to 2012, has been focused on delivering mobile mapping solutions, a lot of which you guys would know, and you know specifically around kind of wearable solutions. The NavVis VLX2 and the VLX3 are wearable devices that allow you to scan very quickly through your environment. But part of that and part of the identity or brand of NavVis was always to produce data quality that was more comparable to terrestrial laser scanners than what you would expect from your traditional kind of mobile mapping systems. But over the last 18 months, our design and engineering teams have been working on, our design and engineering teams have been working on a new product, a new segment, which is trying to compete within this handheld space. And we've seen over the past kind of 10 years that handheld scanning has become a lot more applicable, specifically within the AEC. You want to be able to move around these environments fairly quickly. They're often quite small and confined. So we've been working on this for the past 18 months, and through that, we now have introduced what we're calling the MLX series. So that is a combination of these wearable mobile mapping solutions like the VLX2 and 3, but the latest addition to that is the NavVis MLX. I think the clicker's not working. So our customers and building point customers similar to yourself at Cave Surveys are professionals. You've built up reputation over years around delivering reliable data to your clients. That's why they trust you. That's why they come back to you. How you've been doing that, I can imagine in the past 20, 30 years, I think it was 1989 that you slide, which was not to beat around the bush, but that's the year I was born. So, for the past 30 years, you've been using things like tonal stations. Probably over the past 10 years, you've been using terrestrial laser scanners, and up until more recently, using NavVis VLXs. These are trusted tools that have given you the ability to hand over accurate and reliable data to your clients fairly consistently. And NavVis as an organization are always focused on delivering products that meet those standards. The VLX has done that. It's been proven to do that time and time again over the past 2 or 3 years that it's been in market. So when developing a new product like the MLX, and we'll take you through some of the details about it shortly, that was the number one factor that we had to consistently meet. We would not release a new product to market unless it met the data standards and quality that people have come to expect from NavVis over the past few years. However, some of the products that and two of the products that are in the LX series, the VLX 2 and 3, for some of these projects, the ideal tool should be really easy to transport, quite dynamic to move around site, pretty easy to use, scanning in tight areas, as I mentioned earlier, AEC type projects. These are tight areas with a lot of complex features within the environment, but you still want it to be fast. You want to scan as quickly on site, leave, get your data processed in a usable format and hand it over to your clients. And the VLX, however, being a really fast and robust tool, doesn't give you all of that dynamic abilities. So other companies and competitors have tried for years to meet two fundamental standards, one of which is scanning at speed and being dynamic, whilst meeting the data quality and standards that you'd expect from your hardware. You guys paid a lot of money for these tools. They have to do the job that you expect them to do. However, a lot of these other devices have kind of failed. You always have to sacrifice one for the other. If you're being really fast, you're probably going to lose a bit of your data quality and accuracy. If you're trying to produce really accurate data, you're probably sacrificing on speed. So where's that middle ground? And I think that middle ground is what sets apart a really professional device from the compromise. So what we have done over the past 18 months is focused on trying to redefine the handheld reality capture market. Can we produce a product that gives you the benefits and the value of speed and agility and dynamic scanning, but without sacrificing on our data quality? And that is where we have come to now with the NavVis MLX. So you're a user, left screen, right screen. Can you tell me which screen is a VLX or an MLX?
We win a prize.
MLX. I think left screen is VLX. That is just so good.
Left screen VLX, right screen MLX.
Oh no, that's just it's such good data.
What's the vote? You are left screen VLX.
Yeah, left screen.
I think I'm going right screen VLX. I can't tell the difference.
So I'm going to happily tell you that none of you won a prize because you're all wrong. Both those screens have actually been captured with the MLX. So that kind of tells you, yeah, babush. So and that kind of it solidifies the story, right? We are producing products that produce incredible data quality. That is really hard to tell the difference between a VLX and an MLX when it comes to data quality comparisons. But I need to be clear on the fact that those two products, the wearable solution and the handheld one, are still fit for purpose. And I think you probably know this better than most. Not all scanners can do everything, right? You need the right tool for the right job, and that's where the LX series becomes a line of products that helps you achieve those data quality results that you're looking for. So there it is. that is the NavVis MLX. That was launched in the first or second week of September. And shortly after that, our major launch happened at Intergeo 2024, which took place in Stuttgart this year. So it's a product within our family now. It is a handheld solution that complements our VLX products, and our VLX products themselves complements the NavVis MLX. And as I said earlier, this is absolutely redefining handheld reality capture, producing results that are extremely fast, but at the same time being incredibly reliable. So we can talk through some of the technical features. I know you guys as surveyors love to read into these details. I think it's important that we do. But it is absolutely high quality data. We've got a stable 32-layer LiDAR sensor, some industry trusted SLAM software. NavVis has produced our own SLAM algorithm since 2012. It's trusted, it's reliable, it's dependable. You've seen the results before. Exceptional point cloud quality from a handheld device. I think that previous slide with the side-by-side comparisons shows that. There is not a single handheld device on the market that can produce that level of data quality and accuracy. Obviously, to make that a lot more usable, you need some visual reference or some visual context. So we have 4 cameras producing high resolution 270 images. You can create a 360 panel if you lift the device above your head. Obviously, you don't want to capture your face in the photo, so lift it above your head. However, we do have a fairly unique feature within the software that basically, if you're not taking a 360 panel and you are in the image itself, we remove that image automatically and we replace it with point clouds, that you're not constantly in the scene. It's quite a unique feature. It's really helpful if you want to move around the environment quickly and not carry on having to lift the device above your head. The ergonomics, right? And one of the interesting things that we did at Intergeo was to ask somebody to hold out a 1 liter beer stein out in front of them for as long as they could. And you know, not many people can't last more than 10 minutes. 10 minutes is you know, you're pretty buff at that point in time. So what we've done around the ergonomics is we've actually designed the product for functionality rather than for size or weight. Therefore, we do have a harness that allows you to scan for hours, if need be, without kind of losing grip of the device. The harness is there for a reason. It supports the device, it supports the weight of the device, and allows you to actually do your job rather than focusing on how strong you are. We have the built-in screen, which gives you obviously real-time feedback around the data quality and are you scanning everything? Is it complete? Is the job finished? Can you leave site with confidence? And it has been designed for flat-sided placement on surfaces. It sounds really trivial, but to be able to put the device down and know that it's secure, not going to roll off tables, is actually quite important. These are tools that you spend a lot of money on. So, limitless mobility. You know, as I mentioned earlier, this is now a compact device, which means that you can easily move this device around from site to site. It comes in a backpack. You can easily get this product into your hand luggage. You can move around very quickly. It is incredibly comfortable. The backpack itself it's like walking around with your laptop bag. You can get to site fairly quickly. You can go trains, planes, bikes, cars. We have a handheld luggage on flights. And then at the same time, you also get your hard case, your protective hard case in case you need it. And then one of the really great features about NavVis Tech, and we've brought the same these same features into the MLX that was on the VLX, is your geo-registration. So your ability to actually measure and control on site, which means that you're just creating a much more reliable and much more accurate result. That exact same feature has been brought into the MLX, which means that the consistency across all products is exactly the same. And then you're ensuring complete coverage, as I mentioned earlier. The built-in screen, specifically if we think about users that aren't incredibly knowledgeable around the kind of the use or the understanding of survey, right? Often you want to give these tools to people to really quickly collect data, right? They don't, you don't have to be a genius. If you've got a built-in screen that's telling you quite consistently how much coverage have you got, have you completed the job, is something slipping, something drifting, that real-time feedback just gives you the confidence when that team has come off site, everything's done and it's done properly. So let's go into some of the specs itself. So without getting overly nerdy, the sensor is using a 32-layer laser scanner, a sensor called SI, and we are producing or collecting about 640,000 points per second. We have those 4 12-megapixel cameras with the point cloud filling for the panos in case your face is in it. One thing that the MLX is doing that the VLXs aren't doing, because the VLX has 2 sensors, we have incorporated 2 additional cameras on the MLX, which is called visual odometry. So what that is doing is that is using visual features in the environment to supplement the SLAM. Those 2 additional cameras are not producing any data that comes into your final result. We don't process those images. It's purely there to add some additional robustness and redundancy to the SLAM to ensure that you're getting an accurate result. Current goal is 8 millimeters or less. We have a accuracy white paper that will be produced in Q1 of 2025, individually verified. We don't like to produce these things ourselves, but 8 millimeter accuracy on a handheld device is pretty decent. And then, like I said, we support adding control points using the same technology that came from VLX. Usage. On a single battery, up to 45 minutes of continuous scanning with a standard 98 watt-hour battery. We do actually include a second battery, keep it on charge, pretty much scan all day if you're cycling through these things. 10 hours of scanning with 250 gig external storage. 10 hours of scanning, and if you think about you moving at the same time, that is a that is a lot of data. That is a big old environment. And then the integrated 5.5 in touchscreen, which is built into the device itself. Weight, just under 3.5 kilograms, including the batteries. Actually includes the harness for kind of comfortable mapping. Obviously the backpack is included, so you can transport around, and then obviously the heavy transport case as well. So that is the short and sweet of the NavVis MLX. Obviously, the Building Point guys have their unit here already, which is exciting.
Yeah, to get our hands on it.
Yeah, I think I hand it back to you now, Brett.
Yeah, thanks very much, Sam. So I think we've now heard from the manufacturer. I think now it'll be always good to hear from the user. And I think and fellas, if it really does say if it does what it says on the tin. And it'll be nice to hear from Ian just what Ian does in his business, how he has one of the VLXs and how it's improved, what value it's added to his business and what value it's added to his customers as well. So yeah, thanks Ian, thanks for joining us.
Thanks, Brendan. We're a Cape Town-based firm of land surveyors in South Africa. We've been in this part of the world for the last 50-odd years with a proud history of traditional surveying, with a high commitment to accuracy and innovation and professional advice to our customers and clients. Obviously, as a firm of professional land surveyors, we cover the full spectrum, cadastral, sectional title, and onto the construction engineering side of it, putting in the as-built plans and completion certificates and signing off. So we do the full spectrum. We've realized in this that there is more advanced technologies that are coming out, and we've moved from the traditional theodolite, the steel tape, inverted image, through to this wonderful GPS side of things. And then later we've realized that scanning plays a really important role. That scanning we utilize both in the topographical and site surveys. With construction these days, it's so important to get as much data as possible, get it as accurately as possible. With construction costs rising, it's exceedingly important to get this data over to the guys who are going to make the decisions on what happens on site. And scanning is the natural choice of going ahead and capturing as much data as you can. from the design side leads out into the construction and setting out of the new build that needs to be done. That is exceedingly complex these days with really difficult sites that we work on. And once again, using the right technology to get the stuff out of the ground correctly and set out correctly first time is just so important. This setting out for construction then leads us into the verification that the good old contractor has thrown his concrete where he is supposed to have thrown it. That verification can go from a whole building where all the elements are identified and extracted and compared to the design positions, to your traditional floor flatter scanning, where we reduce the point cloud to every 100 mils instead of every meter, and generate floor flatness plans, which one can see if it meets client spec or whether it needs remedial action to sort it out. And then our little problem child, every site has a lift, and they managed to get them wrong. So verticality analysis, see if it's going to work. The lifts, as you know, are ordered many years before the project, and now it doesn't fit. So yeah, lifts are one of the real bugbears on it. The scanning also helps us with the volumetric surveys, which we do with stockpiles and the budget being what it is these days. It's just more and more important that our client gets the right volumes, and the only way of doing that is to scan it. The old days of running around with a theodolite and taking a few spot shots don't cut it anymore. So scanning, again, exceedingly useful in that side of things. Another aspect of the scanning that is producing as-built plans. These days, people need this for record-keeping purposes. This generally focuses on 2D plans, floor plans, sections, elevations, the typical things that would be as part of a record. The level of detail that's required on those plans, again, is only possible through scanning. To sit there with a tape measure and just not going to cut it anymore. The next level from that is the BIM. Scanning, again, a lot of it in the architectural space, but even more so these days, the structural side of things, the HVAC systems, fire, are all needed. And once again, the only way we can do this is scanning. So the model verification is also very important. That model that the guys generate may not be done from a scan card. It might have been of as-built drawings of a building. Those are either in the PDF, the DWG formats. Might have been collected with an architect or using a tape and a disto. So it's exceedingly important to take that model and verify that it is actually correct, that it matches the building that you're doing. So in this case, we scan the building, drop the model into the point cloud, and then verify that the building is correct. So as you can see from our entire history, we've grown up, modern history, we've grown up with scanners. I think our first scanner was in 2012, 2013, somewhere around there. But we soon acquired a fleet of these little scanners. They are exceedingly useful. And as Sven mentioned, there's no scanner which does everything. Unfortunately, there's no scanner to rule them all. So we acquired a number of the static scanners, and then very recently we moved into the mobile scanning side of things. Our most recent baby to our system is the NavVis VLX. That's proved to be an amazing scanner. It comes in two formats. Two sides to it. Is the VLX is the hardware, and the NavVis Avion is software. And both of those aspects have incredible benefit, both from the surveying side and also from the customer side. So from the surveying side, it just excuse that old man running around there. From the surveying side, it's just made us so much more efficient in the field. There's just really no way of capturing that amount of data that quickly with that amount of coverage. It's just not possible with the TLS, the terrestrial laser scanner. So from the data capture side, huge increased efficiency. From the data modeling side, likewise. In the Avion side of things, this is a split screen mode where on the left-hand side, my left-hand side, you've got the actual physical as-built picture image of the Avion. And on the right-hand side, you've got the Revit model, which we are busy generating. as you move around the model, the images move around with you. So it takes the guessing out of what are you actually physically modeling. Is it a wall? Is it a cupboard? Is it a partition? You can see it. As you're modeling it, you can see it. It's literally like being on site and looking at it and saying, right, fine, I now want to put a wall through here. From our customer's point of view, this is now the interesting side of it. They get value add for what they're wanting. That Avion system in itself is a wealth of information. What happens here is an example of capturing data. And this then gave a value add to our customer, because without changing what their requirement of their deliverable was, we were able to capture the product, process it, and then generate what they had asked for. The quality of this point cloud, the level of detail that we captured on this, the speed at which we captured this is just not possible in any other way of producing this in the tight timelines that we stipulated.
Just look at that data set and it just reminds me of projects done in the past. I'm saying if only project, there's no shadows. It's just like so complete. That's the thing that stands out.
You watch the product, the scanning as it unfolds on the screen, and you look at it, you just take a step, half a meter to the left, fill in the gap, move on down. It just, every aspect of that product gets captured. It is exceedingly well captured. So from that, we were then able to generate the required deliverable. They wanted PDF, DWG of high clearance tolerances, and that was what they wanted, which is fine. We can deliver that. But then as the saying goes, but wait, there's more. There's a whole lot more. So attached to that, we then gave them a spreadsheet showing the points that were not within tolerance with a little hyperlink on the side. And that hyperlink, then they could click through using any web browser to the Avion site. So this then is the Avion site. So if they now want to see a point which is not within tolerance, they can jump immediately to that point. And it then presents it. That's your point, not in tolerance. So they can do a site inspection from a virtual office. They can literally see what is on that site. The digital twin, here's your data captured. And in our case, very little extra cost. We had to scan it, we had to process it, we had to extract it. There's the data for the client.
I think what's very nice with that as well is that you've delivered them an Excel spreadsheet and a PDF. And there's no intimidation about now you're delivering them something new that they have to overcome and they have to learn. You've given them a spreadsheet and it's linked them into something like this, and that now I've got this user interface as a value add without being pushed back. It's not a sell.
Absolutely. Yeah, we found it was so interesting. We gave this to the guys. They analyzed what they wanted to do off the spreadsheet. And in the Avion system, you can set up various user levels. This is hosted on an Amazon web server, so it's as secure as Fort Knox. And then the user levels, you can have viewer, admin, because you don't want people climbing inside here and breaking the system. So from that side, we then issued it, and we found that the most unusual folk were actually wanting to start looking at this and taking measurements. It wasn't just for the design team that wanted it back off. Suddenly this opened up all sorts of new aspects for them. So once again, value add to the client. They were exceedingly happy to get the results within that time frame. There was no way we could have scanned this traditionally with our TLS scanners. So the mobile side of it cut our scanning time by, we did about a third. A third of the scanning time we did that in. Those floors are 12 to 15,000 square meters at a time. And we knocked that off in a day, just under a day, to produce that. And then the processing, analyzing, gave the results, and the clients came back saying, wow, that hopefully they don't have to pay for it. And I said, you already have.
So it's part of the package.
So happy clients, impressed clients, clients that are coming back for more. They're now starting to ask for the data presented in this manner. And for us, it's been an amazing tool, both from the surveying side, processing and delivery side. It's filled all the boxes for us.
What I find quite amazing about this whole thing is that you don't necessarily know what sort of clients are going to be using this data.
100%.
So the clients might not necessarily have a big, powerful, fancy laptop PC that's going to be able to handle this sort of data sets. And what's incredible is that they can just view it off
A web browser.
off a web browser.
Yeah.
Unfortunately, internet connection is still required.
Yeah.
But
So you think about the users in itself, right? Within Ivion, you are able to view the point cloud and utilize those types of tools, but not everyone even understands what a point cloud is, right?
Yeah.
So
a lot of guys, they can click prop and just extract just that little section that they want, so they don't have to puke on billions of points. It's there's a reason.
Yeah,
it works exceedingly well.
So I think, thank you very much again. So that you've heard it from the manufacturer,
Not the horse's mouth. Eh?
That did call me.
So yeah, I don't know if there's any questions. Please, are there any? Do you have any questions in the chat, or please feel free.
I don't like it when he looks like that.
Yeah. Oh, okay, I just brought it. Sorry.
It's a question. How long does it take to get used to the Ivion interface? From a learning curve sort of point of view, it's sort of quite quick and easy. Sending these results to a client who isn't a BIM expert or a CAD expert, how long will it typically take them to, be able to click on the link that Ian's provided them, and then
So it is the whole interface of Ivion is it's very user friendly. It's very intuitive. If you think of if you can navigate Google Earth, Google Street View, it's like that. It's like navigate. I do have a little, surprisingly, I've just got a little video here which actually shows you what the Ivion looks like. Just so you can see that user interface and how easy it is. So from a customer's perspective, for example, this is how you would look at Ivion. It looks like a Google Earth user interface. You can see your sites. You can easily jump into them. You can see on the right-hand side, everything is split up onto a level. That's exactly how you navigate your first floor, your second floor. So while capturing your data, this is what on your device, it splits things up onto levels while capturing, and then while you're processing it, you can also reset up these, redefine the levels of your project. Navigating two different places. Every time Ian presses a button on his VLX, it captures one of these panos, or bubble views, as people are used to the term. You can jump into one of those locations, and you can see obviously the 360 imagery and stuff around you. You can see there's those two views, the split, the 2D view and the 3D view, and you toggle between them as you go around the site. So there's not much sort of.
I think there's a valuable point that Ian made earlier. But this is a web browser. It is a simple web browser. There's no local installations of crazy software licenses on your PC. There's no specific seats. There's no specific laptop being traveled around between teams and individuals. The great thing about a web browser based platform is a lot of these times, and specifically since COVID, you have teams that are absolutely remote. That you might have a team in Joburg that's looking at some of the structural stuff. You might have a team in Cape Town who's looking at some other functions of the site itself. And all of those teams and individuals have access to the exact same information at the exact same time without going through some crazy IT infrastructure. It is type in a web page and have access to all of that information very quickly.
Yeah, you can see also Ian showed sort of by highlighting these points of interest and these things. Yeah, you can see in this little video that's playing sort of a bit more. You can take it to that next level. It doesn't just have to be now. Now we're looking at we've linked in sort of IoT sensors, so that there's vibration sensors on the plant or something like that, and it can be turned into as big or as small as you like. The client can start to add things, information to it. You can tag live video feeds. You can tag maintenance schedules, documents. You can see here on this little big. You can even do you can do navigation, so you can navigate between these points of interest. So it can be used as an indoor navigation tool. I think that. There's a new application with Ivion Go. I actually spoke to us about Ivion.
Yeah, so NavVis Ivion Go is an app that we've released in the last few weeks. Actually, it got released around about the same time as NavVis MLX, which is in essence, giving this to people on site through a handheld device. So the same types of features around the ability to navigate from one specific asset to another, one point of interest to another. It's a really, really powerful tool that, from your client's perspective, again, it's another value add, right? They can start to really utilize the IBM platform within their own kind of maintenance schedules and plans and everything else. It's extremely powerful. And then the ability to add some additional context to things that have already been scanned, right? And can we go up to the same asset again and add some additional information to it and tag it? So yeah, really, really powerful tool. Again, all cloud-based, so very collaborative in its nature. And that navigation tool is actually really, really useful. If you're thinking about sending in a maintenance team to look at that specific machine in itself, that maybe that guy's never been there before, ever. Just a simple feature like that can be really, really powerful.
And from there, you can take distances, measurements, areas, do all that interrogation down the side there.
Exactly.
So yeah.
Mentioned, there you go. Yeah, very useful tool. So it's very easy to navigate. If that answers the original question. Yeah, any more questions?
Yeah, there is another question here from Sakunti Tima. Do you need to take control points to process the captured point cloud, or does it come ready and accurate? And does it not get affected by weather, by cloud coverage?
We'll probably start on the control point question. So in essence, yes, you can capture data quite accurately without control. However, it is absolutely advised that you include control points.
I like to use control.
Yeah.
You know what the data is when you get your control out. Either there's a problem with the control or there's a problem with the data. If you're running blind, if you don't know.
Yeah, exactly. And it's a general kind of rule of thumb that control just means that exactly you have that absolute confidence that it is to the level that you'd expect it to. And obviously it assists in the processing as well, right? It absolutely adds that additional layer of redundancy when processing those data sets. So yes, I would absolutely say use control capture.
On top of that, it gives you, you get out a very good sort of quality report. Because you've done control, you can then prove that the quality of what you've done is correct. There's QA/QC report which shows the deviations between your control and your SLAM data, and you can actually then, with confidence, say, I know it's right, and I've got a record to put into my QA file that it's tick that box.
But what was interesting on that project that we did is the raw data, when you upload it, it gives you a projected of what is happening at the moment. And I think my worst error there was about 13 millimeters on that entire 140, 150 long meter. So I was, worst point stuck out at 13, and then after processing, we're down to around 2 millimeters. So it's exceedingly accurate.
Yeah, and I think that there's something to be said around the quality of capture in itself. So clearly whoever was doing it really knew what they were doing at the same time, right? The planning of those projects is also crucial around.
Yes, you don't walk onto site and think I'm going to go and scan here. You have to plan it.
Yeah, absolutely.
They received good training.
I think just to cap off that question, I think there was a topic around weather. So
Yes.
yeah, so cloud coverage won't have an issue. I think maybe only the one thing it might impact is image quality, but we do some white balancing on the images when processed. I think in general with any scanning, just don't scan in the rain.
Don't scan the rain.
That's about it.
Okay, well, I think that's come to the end of the questions that people have put in the chat box. Please, so this has been recorded. It will be made available to you. So please share it with your colleagues. If you want to get a hold of Building Point here, or this is where you can get hold of us on our social media tags and our website. So yeah, I just want to thank you, Sven. Thank you, Ian.
Thank you, guys.
Thanks thank you very much. And yeah, thank you guys for watching. We'll call it there.
Thanks.
Thank you.
Thanks. Good.
Thanks.